Benchmark. Apart from unit tests, the Golang testing package also supports benchmarking. Benchmarks are a mechanism for calculating the performance speed of our application code. Benchmarking in Golang is done by automatically iterating the code that we call many times until a certain time. We don't need to determine the number of iterations and their duration because that is already set by the default testing. B from the testing package. Testing.B. Testing.B is the struct used to benchmark. Testing.B is similar to testing. T. There are functions fail, fail now, error, fatal, and others. What is different is that there are several additional attributes and functions used to benchmark. One of them is the n attribute. This is used to carry out the total iterations of a benchmark. How benchmarks work. The way benchmarks work in Golang is very simple. How about we only need to repeat a number of n attributes? Later, Golang will automatically execute a specified number of iterations automatically, then detect how long the process has been running, and conclude its benchmark performance in time. Create benchmark. Similar to unit tests, even for benchmarks, in Golang the function name has been determined. It must begin with the word benchmark. For example, benchmark hello world, benchmark suck. Additionally, it must have a parameter btesting.b, and it cannot return a return value. For benchmark file names, the same as unit tests, end with test. For example, hello world test. Go. In this code, the function benchmark hello world is used to measure the performance of the hello world function when called with the input James. This is part of Go's benchmarking framework, which helps developers assess how efficiently a function runs, particularly under repetitive or heavy use. The function begins with a loop that runs for b, and iterations where b en is automatically set by Go's benchmarking tool to determine how many times the code inside the loop should be executed. Each iteration calls one hello world James, simulating repeated calls to this function. Running benchmark. To run all the benchmarks in the module, we can use the same command as test, but add the bench parameter, go test vbench equals. If we just want to run benchmarks without unit tests, we can use the command, go test vrun equals not mathunitis bench equals. The code above, apart from running benchmarks, will also run unit tests. If we only want to run certain benchmarks, we can use the command, go test vrun equals not mathunitis bench equals BenchmarkTest. If we run the benchmark on the root module and want all modules to run, we can use the command, go test vbench equals /. We will try to run the test by simply running the command, go test vbenchmark with the same function name. By running the benchmark multiple times, Go collects performance data, such as the average time per operation and the number of iterations. This benchmarking process helps developers understand how well Hello World scales with repeated usage. It can reveal potential bottlenecks or inefficiencies in the function's implementation. Benchmark results can also be compared over time, enabling the team to optimize the function for better performance if needed. By using this approach, the developer gains insight into how the function behaves in scenarios with a high volume of calls. Sub-benchmark. Just like testing.tt in testing.B, we can also create sub-benchmarks using the run function. When we run the benchmark function, all sub-benchmarks will run. However, if we want to run just one of the sub-benchmarks, we can use the command go test vbench equals benchmark name / subname. Now we will try the subtest benchmark. The method is almost the same as the previous subtest. Now we just copy the existing run function. We copy it twice. Next, we try it. The results can be seen. All the benchmarks from the subtest are displayed. Table benchmark. Just like in unit tests, Golang programmers are used to creating benchmark tables too. This is used so that we can easily carry out performance tests with different data combinations without having to create many benchmark functions. As usual, to create a test table is the same as the previous test table. The difference is that the parameters use testing.B. We first create a list of object structs with name and request attributes. Then create a looping benchmark. After that, we try to run it. The results are almost the same as the previous subtest. Finally, the tutorial process on the Golang unit test has ended. Next, we will discuss Go Routine, Go Database, and Go Web. See you!